Welcome back, everyone. In this lecture, we're going to talk about nested statements and scope. We've gone over already how to write our own functions, and we've even gotten a little bit of practice with them. However, it's important to understand how Python deals with the variable names you assign. When you create a variable name in Python, that name is stored in what's called the namespace. And variable names also have a scope, and the scope determines the visibility of that variable name to other parts of your code. So if you've ever wondered why you've gotten some errors that say something like, this variable is not defined, we're going to explore why that happens and how to fix those errors in the future. Let's get started. Okay, the first thing we're going to do is with a little thought experiment, and then we're going to explore the results. Right now, I'm going to say x is equal to 25, and below that, I will create a function. It's going to be called printer. Make sure you don't call it print, otherwise we'll overwrite the print function. But all this does is it sets x equal to 50, and then it returns x. So let's run this. And now I want to ask you, what do you expect to happen when I say print x? Do you expect to see 25 or 50? So when I run this, I get back 25. And if you had the intuition that it's going to be 25, that's great. And if you had the intuition that it's going to be 50, don't worry, that's exactly what this lecture is here to explain. What I want to show you is if I say printer, open close parentheses, so I'm actually running the result of printer and returning the x here, then I get back 50. So when I print out x, I get 25, and when I print out the result of printer, I get 50. So this is quite interesting, but the question we want to answer is, how does Python actually know which x assignment I'm referring to in my code? Am I referring to this x is equal to 25, or am I referring to this x is equal to 50? And why doesn't this reassignment seem to affect the assignment up here when I later on asked for print x? And this is because the idea of scope allows Python to understand and have a set of rules to decide which variables you're referencing in your code. And these rules are a LEGB rule format. So LEGB stands for local, enclosing function locals, global, and built-in. So let's take a look at this. So this is the LEGB rule, and this is essentially the order that Python is going to look for variables in. And it starts off by checking out the local namespace. And these are names that are assigned in any way within a function, such as df or inside a lambda call. And they're not declared global in that function. And later on, we'll see what we mean by declared global that uses a global keyword. So first, Python's going to say, hey, if you call that variable, is it in my local namespace? Then it's going to check for enclosing function locals. And these are names in the local scope of any and all enclosing functions from inner to outer. So you can actually have functions inside of functions, which you're going to see in just a second. Then it looks for the variable, if it still can't find it, in the global namespace. And these are names assigned at the top level of a module file or declared global in a DEF within the file. Then it looks in the built-in namespace. So these are names that are pre-assigned in the built-in names module. Things like open, range, list, str, syntax errors, etc. Built-in keywords in Python that you see have those special syntax highlighting rules to them. Let's explore what each of these looks like: local, enclosing function locals, global, and built-in. We'll start off with an example of local. So an example of local would be something like inside a lambda function. If we were to say num num to the power of 2, this is an example of a local variable. So num right here is local to this lambda expression. Let's now see an example of enclosing function locals. So we'll go ahead and just comment this out. In order to show you an example of enclosing function locals, we first need to create a function and then put a function inside of it. So I'm going to say name at the very top of this. Notice the indentation and say this is a global string. Then I will create a function called greet. It takes in no arguments, and inside of this I say name is equal to Sammy. So I'm overriding that name variable here. And then inside of this function I'm going to say hello, and I'm going to say, hey, print hello concatenated with name. And then I'm going to call hello, and then I'm going to call greet. All right, so there's a lot going on here, especially since there's a function inside a function. So let's break this one down. Here, I have a function called greet, and what it does inside of it, it sets the variable name equal to Sammy. Then, inside of the greet function, so notice how all of this right here that I have highlighted is inside of greet because of the indentation. We have def, then the hello function, and inside the hello function, I ask, hey, print out hello name. And right now we have name defined twice, up here as a global, and then over here as an enclosing function local. And after we define hello, inside of greet, I'm actually going to call and execute hello, and then I will call greet. So let's see what happens when we run this. We get back hello Sammy when I actually execute greet. So what's actually happening here? Well, when I execute greet, and in fact we can put this in a new cell so that's a little more clear what's happening. So greet's kind of separate. That greet call is separate from the definition of greet. When I call greet, what happens is I'm calling and executing the greet function. It assigns name equal to Sammy, and then it defines this function hello, and then it calls the function hello. So when you call greet, internally, it's creating this variable name, it's defining this function hello, and then it's executing this function hello. This is going to follow this LEGB rule when we want to figure out, well, what name are you referring to? So first off, we look in the local namespace. So the local namespace, as we just discussed, is within a function. So here in the function, def hello, it's going to say, hey, did I define name anywhere? If it can't find it, then it goes to the next level. So after searching local, we go to enclosing function locals. So we have this enclosing function because this function is inside of this function. And then here, we do find that name has been defined. It's equal to Sammy. So that's the one we choose when we finally execute hello here. And that's why you see hello Sammy. Now let's see what happens if I were to comment this out. So now I've commented out Sammy. And if I run this again, and I run that again, now I see hello, this is a global string. So what's happening now? Well, we're going through the same rules. We first look at local. So when we execute hello here, this hello function says, well, I got to figure out what variable name is. I don't see it defined locally. And now, since this is commented, I don't see it defined in the enclosing function. So then I'm going to go to the next step, which is to look globally. And there it is in the global level. This is a global string. And global is defined by basically having no indentation. It's all the way to the left, either in your script or in your Jupyter Notebook cell. And because it found it in the global namespace, it now says, hello, this is a global string. Let's see what happens if we uncomment this and we say name equals Sammy. So I want to kind of label these right now. This is the global. This one right here is enclosing. And let's make a local one. So local is going to be name is equal to I'm a local. And now when we rerun this to redefine this function, and I call greet, it gets back, hello, I'm a local. Because when you execute hello, that executes this function right here, which says, hey, Python, figure out what is this name variable assigned to. And it immediately finds it in the local namespace right here, name, I'm a local, so that's what it uses. As you can comment these out, it'll look in the next level, meaning the enclosing functions. If you comment that one out, it will then look in the global namespace level. And the only level above global is the built-in function level, which would be something like a built-in function as length. So you should always be careful not to overwrite these built-in function names, and they're always indicated to you with syntax highlighting. And if you're not sure, if you're able to call help on it, and you see some stuff pop out, then it's definitely built in because it already has that information. Finally, to close off this discussion, what we're going to do is look back at our original thought experiment, this assignment of x25 at the global level, reassigning it at the local level, returning the local assignment, but still being able to print out both when we wanted to. We could print out the global one, or we could return that local one and print that out as well. So we're going to discuss local variables as well as the global keyword. So we're going to show you an example of that thought experiment again. We'll say x is equal to 50. And I'm going to create a function that takes in x. And it's going to print, using f-string notation, x is x right here. So let's run that. And let's see what happens when we call function x. It says x is 50. Perfect. Now, also inside this function, I'm going to reassign x locally. So this is a local reassignment. And then I'm going to print I just locally changed x to, and then we'll insert x right there. And make sure your x variable is lowercase here if it was lowercase there. So now we rerun this cell to redefine that function, and now I see x is 50, I just locally changed x to be 200. Now, outside of this, what happens if I print x? Well, I get back x is 50, even though inside of this function I reassigned it to be 200. And this is because this reassignment is only happening in the local namespace inside of this function. It's not going to affect anything at a higher scope. So this is what scope really is. It's the fact that when you declare variables inside of a function definition, such as what we've done here, those variable names only have a scope local to this function. So that's the scope of this variable x right here when we assign it inside of this function. We have an x here floating around in the global space, but this local reassignment, its scope won't be able to extend outside to another level, which is why, after all, we're still able to print out x here as 50. So let's imagine you're in a situation where, for whatever reason, you actually did want to grab this global x and reassign it to be 200. How could you do that? Well, in that case, we won't actually accept x as a parameter. Instead, what we're going to do is inside our function, at the very first line, we're going to declare the global keyword here, and then say x. And what this does is, instead of passing in x, we're going to declare a global x, and that tells Python, hey, I want to go to the namespace, jump to the global level, and grab the x variable there. And then what I want you to do is anything that happens inside the scope of this assignment, it's going to affect that global x. So we're going to grab that global x, report what it is. We're going to do a local reassignment, except now it's on a global variable, meaning it will have an effect to this guy up here, 50. And then we're going to print, I just locally changed global x to some other value. Okay, so let's run this again, and I'm going to, instead of having this be 200, I'm going to make it super obvious that we're changing it by saying new value. So x used to be a number 50. I'm going to, when I call this function, reach into the global namespace, grab that x, report back what it is, change it to the string new value, and display, hey, I just locally changed global x. So let's run this. And I'm going to create a couple more cells here using Alt-Enter just so we get kind of a clean slate. So I just ran this, and let's see what happens when I actually call it. So right now I just defined the function. I haven't actually executed it yet. So when I right now say print x, I still have 50 there. Let's see what happens when I execute the function. It says, hey, x is 50, as we just saw, and now it's reporting back, I just locally changed the global x to the string new value. And now let's see what happens when I print out x. It says new value. So using the global keyword, you're able to reach out into that global namespace, and then your local assignments do affect that global variable. Now, because of the power of this global keyword to do that, in general, especially if you're a beginner, you should avoid using that global keyword unless absolutely necessary. Instead, what you should be doing is if you want to grab that global variable and then affect it, you should take it in as a parameter, do the reassignment, and then return the reassignment as an object itself. So let me show you why you would want to do that. So now that I ran that, if I print out x, x is still 50, and then I'm going to say func of x, and then I will say x is now equal to func of x. So x is 50, I just locally changed, and I should have deleted this, it's no longer that global variable, but technically, now when I call x, it's been reassigned to the string new value because I returned x and I reassigned the global level x using that function. And in general, this is a much better path to take than using that global keyword. So even though this combined with this is the same thing as the global keyword, it's much cleaner and much safer because you'd have to know that you want this reassignment to take place somewhere else in your code. It's quite dangerous to have the reassignment take place with the global keyword because as you use larger and larger scripts and you have separate scripts interacting with each other, you may accidentally overwrite global keyword inside of a function without ever knowing it. And that makes it a lot harder to debug. It's a lot easier to debug something like this because there's a clear reassignment happening here where we specifically grabbed that global x and said, hey, now make that equal to the output of whatever this function is. And later on, when you have your first milestone 1 project, that's the pathway we're going to recommend taking for dealing with certain objects in that global namespace. Okay, definitely a more complex topic, but hopefully it allows you to build an intuition of nested statements and more importantly, the scope of variables. Thanks everyone, and we'll see you at the next lecture.